Ever wondered why the size of particles matters so much in adsorption? Well, you're about to find out. Adsorption, at its core, is a surface phenomenon. It's the process where particles of a gas, liquid, or dissolved solids adhere to a surface. It's like a party where everyone wants to stick to the wall, and the wall is the surface of our adsorbent. But here's the twist. Not all guests at this party are created equal. Some are big, some are small, and this variation in size is critical. Why, you ask? Because the size of these particles determines the total surface area that's available for adsorption. Smaller particles mean a larger surface area, providing more sites for adsorption. It's like having more wall space at our party for guests to stick to. So the size of the particles directly influences the adsorption capacity. Now that you understand the basics of adsorption, let's delve a bit deeper into how particle size comes into play. So, how does particle size affect adsorption? The answer lies in the surface area. It's a fascinating dance of physics and chemistry, where smaller can often mean mightier. Let's delve into the heart of the matter. You see, when we speak of smaller particles, we're not just talking about tiny bits of matter. We're referring to a world where the surface area balloons, providing more sites for adsorption to occur. Imagine it as a bustling city. The more buildings there are, the more people it can accommodate. Similarly, the more surface area an adsorbent particle has, the more molecules it can hold on to. Now think of the adsorbent particle as a sponge. A larger sponge may seem like it can hold more water, but if it's all one big chunk, the water can only soak into the outer layer. But if you break that sponge into smaller pieces, suddenly there's more surface area exposed and more water can be absorbed. That's the power of smaller particle size for you. It's all about maximizing the surface area for adsorption. But there's another side to this story. Smaller particles don't just provide more adsorption sites, they also allow for quicker adsorption. This is because smaller particles have shorter diffusion paths. Imagine you're in a maze. The smaller the maze, the quicker you can find your way out. Similarly, in the microscopic world of adsorption, molecules can find their adsorption sites faster on smaller particles because they simply have less distance to travel. So in a nutshell, the smaller the particle size, the greater the surface area, and the quicker the adsorption. It's like a double win for smaller particles in the world of adsorption. It's clear that particle size isn't just a minor detail in adsorption, it's a key player. So next time you think about adsorption, remember, size does matter, but smaller can often be better. So we have seen how particle size plays a significant role in adsorption. To recap, let's remember that particle size is a key player in determining the efficiency of adsorption. As we've seen, the smaller the particle size, the larger the surface area. This larger surface area provides more sites for adsorption to occur, enhancing the adsorption capacity. In essence, each tiny particle is a stage for potential adsorption. Imagine a bustling city. The more buildings it has, the more people it can accommodate. Similarly, the more sites available for adsorption, the greater its ability to trap and hold particles. Moreover, smaller particles not only increase the capacity for adsorption, but also speed up the process. Just like how a smaller city can fill up faster than a larger one. And there you have it, the fascinating interplay between particle size and adsorption. Remember, in the world of chemistry, even the smallest changes can have a big impact.